Hey everybody, welcome back. In this video I want to go over how to use what we know now. So I've introduced three rules of inference so far. One with respect to conditional statements, that's modus ponens or arrow out, which I'll go ahead and put this little list up here. So we've done arrow out, which looks like this. You've got this pattern. You've got an arrow, you've got the left side of the arrow by itself. You can get the right side of the arrow. We've got and out, which is a rule of inference that has to do with conjunctions. That allows us, if we've got a conjoined statement, to simply, we can break it apart. Break those pieces apart, and then and in. If we've got any two things, we can put them together in any order that we want. And keep in mind these letters here, these are variables. Actually, you could have more sophisticated things in there. So the A could be something bigger than that, but so long as it fits any of these patterns, you can do any of these rules, or I'll call them moves. Think of it kind of like a game. Like, can you do this move? And basically, this is going to be your strategy at this point in the semester, and this will only be added onto. Right now, where we are, see if you can do this. If you can, or even if you can't, move on to this one. Can I do this? Do it. And then see if you can move on to this one. This one kind of becomes a should I do this? Like, would it be worthwhile? If you got two things, you can always put them together. The question is, should you? So here's the deal. Again, if you can do this, do it. If you can do this, do it. And then if you should do this, do it. That's going to be your repertoire, at least at this point in this class. Now, with that in mind, let's look and do these three problems. These are actually out of your textbook on page 33. We're going to combine all three of these skills, and it's only going to involve these three skills. So what we're going to do here is we'll take a look at this one. We've got these two assumptions. All of these start with two assumptions. We'll start with this one. We've got these two assumptions. Line 1, A and C. Line 2, we've got B. Can we do it? So first question, can we do an arrow out? We'll go over there. No arrows? Nope. Moving on. Can we do an and out? That is to say, do we have any dots there, not constrained by parentheses, that we can shatter to bits? There's one right there. Break it apart. Look, it's made of two things, A and C, so we just break those apart. So we get A and C separately. And out on line 1 for both. Now for this one, I have what we're supposed to solve for at the very top. We're supposed to get A and B, parentheses around that, and C. So what we need to start doing is now, look, we've got every single atom here of this logical problem, every tiniest piece that we could have, all broken down. What we need to do now is build this. We need to get A and B conjoined, and then conjoin the C onto it. So we need to build A and B, and then build C onto that. Well, can we use this to do that? No. Can we use this to do that? No, we've already broken everything down that we could. Well, let's start building. First thing we need to build is A and B. What do? We built it, so we're using and in. Where did we get these pieces now? Where was A? A was on line 3. Where was B? B was on line 2. Bam. Is this done? Nope. We need to get A and B and C. We've got A and B. What do we need to do? Conjoin A and B to C. Do I have A and B? Yep. Do I have C? Yep. We'll conjoin those things together. And when I do that, since I'm conjoining onto this is going to get parentheses around it because it's taken as a whole unit. So I'm going to get now A and B and C and in. Where was the A and B? Line 5. Where was the C? Line 4. Is my last line a match of this? Yep, this proof is done. You have these two assumptions, you'll get this. How? I just proved it. This one. We got any arrows? We're going to match to the left side. You might say, well, I've got an arrow here, and I've got an arrow here, and hey, look, I've got the match to each of the left side. No, you don't. And here's why. These pieces are in parentheses. That means they're locked in. You can't do anything with them until you unlock them. But why? Well, that's just how logic works. Okay? Philosophy class is not the place to ask questions. That's a joke. Not a good one at that. But here's what you need to do. In order to use this, we're going to have to break this stuff apart. Well, how do we do that? Do we have any rules that allow us to break things down? We can't do this yet because, like I said, the stuff's in parentheses. It's locked. Do we have any ands we could break apart? Yeah. One here and one here. Which one should we do first? Really doesn't matter. In logic, as long as you can do something, it's always appropriate to do it. I personally like to start from the top and work my way down. So this one breaks down into these two things. D and E. What do we do there? And out. Both of these from line 1. we do any arrow outs yet? Nope. Let's go ahead and break this one down. That gets us these two things. D arrow F unlocked from its parentheses, and E arrow G also unlocked from its parentheses. That's and out on line 2 for both. Well, how do I know that, Professor? Well, both of these came from line 2. But now they're unhinged from each other, so they're unlocked. Now, look at it again. Look what we've got so far. Can we do any arrow outs now? Do we have any arrows freed from parentheses? 2. Do we have a match for the left side of this? Yep. Do we have a match for the left side of this? Yep. So now we can deduce really either one. Well, let's go ahead and do this one first. Arrow, left side match, that gets us the right side by itself. That gets us F. How? Arrow out. And here's what we need to do. Where do we get those pieces? Where was the arrow that we just used? Line 5. Where was the left side by itself? Line 3. Can we do another one? We already said we could. Arrow, left side match gets us this G. That's arrow out. 6 and 4 in this case. What are we trying to get? F and G. Well, can we do an arrow out to get that? No. And out, we've already broken everything down. This is where we can and should do an and in. We can take these two things and join them together, build what we need. We get F and G, and in. Where do those pieces come from? 7 and 8. And finally, let's do this last one. Arrow out. Nope. We've almost got a match to the left side. It's not identical. We got to switch this around. How do we switch it around? Well, there's a rule later on that will allow you to switch it. But for now, what we need to do is let's break it down. I and H. That's and out on line 2. For both of these, let's rebuild it in the order that we want. H and I. And N. 4 and 3. If you put 3 and 4, that's fine. I don't care about the order of the numbers, just that they're the right numbers. Can we do an arrow out now? Yep, we got a match to the left side. That gets us J and K. Arrow out, 1 and 5. What are we trying to solve for? Way up there? J. Now you notice we got J and K here. Just break apart the J. Now you might think, well, what do I do with the K? I don't need to do anything with it because the J is all that we need. So we can just say J and out, line 6. Now, if you're worrying about what to do with that K, you can stick the K under there as well, and you can say this problem is done. So that's how to use all 3 of these rules, arrow out, and in conjunction with one another. In the next video, I'm going to go over something going back to conditionals, and actually I think I spent a little bit of time talking about some translational aspects, and then we'll go into some more stuff about conditionals and how they can get a little bit even more frustrating. Some other translational features like talking about only if, and I'll also introduce conditional proof.